All right, so we are moving on to our section 4 here, still dealing with these linear regressions that we have. So now we're going to be looking at the inference of for slope of linear regression. So what we're going to be looking at here is that when we get our linear regression, we're basically going to be asking ourselves, is that the slope? How sure are we that that's the slope? But we're not saying is it the exact slope. We're asking more, is it a range? So is the slope about that point? So is the slope between -2 and -3? Is the slope between 0 and 4? Is the slope, is the slope positive? Is the slope negative? So we're going to be asking and doing inference on those, trying to identify and confirm within a percentage if the slope is positive, negative, or within some sort of range of numbers. We're going to be looking mostly if it's positive or negative for these. So the midterm and unemployment. So let's say we have this data. So this is the percent of unemployment for presidents during their midterms. So if you remember, and you have your general elections on every 4 years, you have the big one, the presidential elections, and then every 2 years, representatives have to be elected. So they are elected the same year as presidents, and then 2 years into his term, they can be elected again. And so this is looking at the data of midterm elections. And so this is wanting to see if a high unemployment level, okay, means that the president's party will do worse at midterms, so they lose more seats. So along the x-axis, we have the percent of unemployment from basically a little short of 0 all the way up to 12. And then the y-axis is the percent change in the number of seats for the House of Representatives. So as you see down here, these are all negative, so that means they all lost seats. While up here, that means they gained seats. So if you look at this, only Clinton in 98 and Bush in 02 actually gained seats during a midterm. Okay, and you see all the other ones that they have listed here, a couple other ones. And then we have a regression line. So we have all these points, and we have a regression line. Okay. So the first thing I want to ask, though, is that 2 points on here are missing, which if you know a lot about history, you'll go, wait a second, there's 2 points that are missing from here, and that's during the Great Depression in 1934 and 1938. Those have been removed because of the reason why we're not using it in this data is because the unemployment rates were 21% and 18% respectively. So my question for you is, do you agree that when we're doing this, that we remove those 2 data points? So should we have removed the 2 points from the Great Depression? If so, if we should have removed them like we did, why do you think we should have? And if we shouldn't have, why? Okay, so take a second and think about why you think we should or should not have those points in them, and the explanation why. So not just yes or no, but you also need to know why. Okay, so with this one, the reason why they were removed is because if we look at the percent of unemployment, we end up at a maximum of about 11, okay? And so 18 and 21 would put us way over here on this side of the, it put us way over on one side of the graph, separated from basically the cloud. So remember we were talking about all the points that were highly influential. Those 2 points could be highly influential depending on what the percent is of the house. But because they're way far away from the rest of the cloud, they could throw off the rest of it. So that's why they have been removed. And because the Great Depression was a time of, it was very unusual compared to the rest of the U.S. As you can see, there are other times where you have high unemployment, but not where it's basically double those numbers. I mean, 21% would be double right there, or right about there, would be double there, and 18 would be double right about here. So as you see, those are major outliers, and that's why they were removed. Okay, so this is the line of regression. So let's say all this data was used. I think there's 27 pieces of data, 29 pieces of data, something like that. So this is the line of regression that was used. So the line of regression was used was y hat is equal to negative 6.7142 minus 1.0010x. Okay, So that is the line of regression, which is the solid line in this graph. Okay, so that solid line is what's shown there. Okay, so based on this equation, would you say that as unemployment increases, the percent change in the house will also change negatively? Okay, so as unemployment increases, would the percent in the house decrease? The answer is yes. And the reason for that is just looking at the slope. The slope is negative. So since the slope is negative, as the x increases, the y decreases. And then vice versa. If the x decreases, the y increases. Okay? And so that's what happens with those. Okay? So by looking at this, by seeing if it changes, we can just look at the slope. So now what we want to do is we want to know, okay, well, how sure is our estimate of this? So are we 90% sure? Are we 95% sure? Are we 99% sure? Okay, how sure are we? So what we have to do here is that we have to do a hypothesis test. Remember our 7 to 8 steps that we have to do? Don't worry, you do not have to do 7 or 8 steps. Okay, instead it's a lot shorter. You don't have to do that extreme formal hypothesis test write-up. Main thing here is you have to make sure you have step 1. So step 1 with these is stating about what the slope is, so how the slope is working. So HO is where beta sub 1 is greater than or equal to 0. And that's basically saying is that the linear function is 0. The slope is either 0 or more. But what we wanted to test and see is we wanted to see if as unemployment increases, the number of house seats decrease, or the percent change decreases, which is where our second hypothesis is what we want to look for. Our alternative hypothesis, H1, which is beta sub 1, beta sub 1 is less than 0. Or in other words, the true linear model has a slope of less than 0. This means that the higher unemployment, so this is just going into detail. So in this case, since we want to prove that the slope is negative, in this case, this is how we would write it. If we wanted to prove that the slope was positive, it would be flipped. Okay, so it'd be that the beta would be greater than would be our alternative hypothesis. If we want to just say it's not 0, then it would be the equal and not equal to 0 stuff. So in this case, we want to prove that the slope is negative. Okay, so next thing is, do we use a t or a z, okay, for this? And since we only had, for the most part, you're going to be dealing with t's because you're going to have less than 30 data points. And so since we have less than 30 data points, we end up dealing with just a t distribution here. And so our degree of freedom when we're calculating it is going to be n minus 2. So it's not the n minus 1, it's not the multiplication of the 2, it's n minus 2 for your degree of freedom. Okay, so for these you're going to be using t distributions and you're going to be using a degree of freedom of n minus 2. Alright, so what's going to be happening is that you're going to usually be given some sort of table, okay, for these. So you're going to be given some sort of table because a lot of this stuff is calculated through computer programs and different things like that. So you won't be having to find individual numbers. Okay, so you'll be given this table, like something like this. Sometimes there'll be less stuff on it, but this is the main information that you need. Okay, so here's our equation. This is talking about the what is it, B1 or B0 and B1. Okay, so each column, it's got your coefficient or the calculated number, it's got the standard error, it's got a t and a p. Sometimes these numbers won't be there. And then it tells you what your s is, your r squared, and then your r squared adjusted, so the percent, which is basically the r, the percent change. So by looking at this, this is just kind of your basic information. And again, this is going to be usually given to you. So to find the t, what you're going to do is you're going to take your estimate and subtract it by the null and divide it by the standard error of the slope. So this is all based on our B1, okay, which is in this case is for unemployment. So in this case, I want you to take a second. I want you to take the estimated number, okay. I want you to subtract it by the null value, which was given in step 1, so our hypothesis. And then the standard error for unemployment. See what you calculate for t. Okay, so if you plugged everything in, you should end up with negative 1.001, which is the slope, minus 0, which was in our null hypothesis. and then the standard error, which is the SE coefficient right there. So 0. Right there, 0.87. SE is standard error, obviously. And we calculated our t-value as negative 1.15. Okay, so our t-value was 1.15. So now we've got to see, okay, does that fit? How does that fit in our data? Okay, so in this case, you're also not going to be given any type of alpha, or you're not given a p-value to reference off of. So in this case, what you have to do is you have to take it based on the table. So checking the p-value. So what we want to do is we want a p-value that's going to be at 0.1 or less usually. Okay, and so we take our t-value, which positive or negative doesn't matter. It doesn't matter if it's positive or negative. We just want the number, so you can take the absolute value of it. We look at our degree of freedom row, which is 25, because there was 27 points. So 27 minus 2 is 25. Now, with this one, was this a 1 or 2 tail experiment? So think, was it greater than, or was it not equal to? Was it less than? Was it not equal to? Which one was it? So was it a 1 or 2 tail? In this case, it's a 1 tail because we just wanted to see if it was less than 0. So that means we're not looking at the bottom row, we're looking at the top row, okay, for this. So when we do our comparison, so we got a number of 1.15. So now we go in our row 25 and go, okay, 1.15, is that between these two numbers? No. Okay. Is that between these two numbers? No. Is that between these two numbers? No. Is that between these two? No. We're getting closer though. Is it between these two? Yes. So that means that our answer is going to be between those two for our one tail, our p-value basically, is going to be between 0.1 and 0.25. We want our p-value, so this number, to be less than 0.1. Is it going to be less than 0.1? The answer is no, because it's going to be between 0.1 and 0.25. So we could conclude that we do not have enough information to prove that it's going to be a negative slope. Okay, so in this case, we would end up failing to reject the null hypothesis. So the null hypothesis was that it is equal to or greater than 0. We'd be unable to disprove that statement. Okay, so we can't prove that it is a negative slope based on the information we have. We either need more information or anything. And the reason is because that t-value that we calculated, 1.15, is between 1.316, which is 90%, and 0.684, which you can think of as 50%. So we're somewhere between 90 and 50% sure, or 50 and 90% sure in this case. Okay, so the p-value right here, 50 and 90, but we want to make sure we're at least 90% sure. Okay, so that means that we needed a t-value that was greater than 1.316 in this example to be able to say yes, we're probably sure. Okay, so we want it more than 90. If it's less than 90, then we cannot calculate it. Okay, so use the output of the formula, evaluate this. Okay, so with this one, I want you to take a second. I want you to go, okay, the null hypothesis of the true value of the regression is 0, and the slope is not 0. Okay, so take a second, work through this, see if you can prove or disprove that or be unable to prove that the regression line of here has a slope of 0 or not 0. Okay, so when you calculated this all the way through, okay, here is your slope, here's your SE, and since we're dealing with 0, that means that when we do our setup, it's going to be negative 0.04307 minus 0 all over 0.01081. When we calculate that, we end up with negative 3.985. So now what we want to do is we want to look at that, go back to our table right here, okay? And as you notice, if you look at your t-sheet, if you look at the first column, since we're dealing with 2 tail in this case, okay? If you look at your first column, many of them, okay, are less than 3. So in this case, yeah, you could probably justify that the slope is not 0, that the slope is something else. because this t-value makes our p-value less than 0.1 in this case.